This is Module 1, Lesson 25, titled A Fraction as a Percent. The goals of this lesson: I can write a fraction and decimal as a percent, and I can write a percent as a fraction or a decimal. As always, pause the video anytime that you need to, rewatch parts as many times as you need to, and make sure that you take good notes throughout. Let's start by looking at example number 1. So Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, etc. Okay? Well, first of all, 50% would mean 50 out of 100. And 50 out of 100 can be simplified to mean 1/2. If I looked at a 10 by 10 grid, this would be 50%. Half of it is colored in. Half of the whole thing is colored in. Are half of those vehicles cars? To use the 10 by 10 grid to disprove it, we could say that we have 1, 2, 3, 4, 5 parts that are vehicles. So what if we split this 10 by 10 grid into 5 equal parts? To do that, I'm going to circle 20 of those in 1. That's 1 equal part. 2 equal parts. 3 equal parts. 4 and 5. If it was 50%, this part would be car, 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 and this one would be truck and truck. Well, as you see, this whole part right here is not colored in. Matter of fact, Sam should have said that 60% of those are cars. 60% of the vehicles are cars. 3 out of 5. So we just disproved it. So we showed that he was wrong by using a 10 by 10 grid. I want to show you a couple more models that we could use. How about a double number line? What if I show a double number line by going percent on the top, and this would be the number of vehicles, I'm going to abbreviate, on the bottom. 0 vehicles would match up with 0%. 100 vehicles, or 100%, would match up with 5 total vehicles. Well, what if we split this down here into 5 equal pieces? We'd have to split this up into 5 equal pieces. If we have a total of 100% on the top split up into 5, 100 divided by 5 is 20. Which means we're going to go up by 20%. And then, if we look, 3 vehicles are cars, it doesn't match up with 50%, it matches up with 60%. So again, 3 out of 5 vehicles is 60%. Sorry, Sam, you're wrong. We could even use a tape diagram. We could have cars and trucks. 3 equal pieces for the cars, 2 for the trucks, and all of this would represent the total. If the total would represent 100%, and we divide that by 5 equal pieces, we get 20% for each of those. And then if we're talking cars, we have 3 pieces of 20, which again, 3 times 20 is 60%. So 60% of the vehicles are cars. Now the next question says, how is the fraction of the cars related to the percent? We saw that the fraction was 3 out of 5. 3 out of 5, 3/5, equals 60 out of 100. which equals 60%. Notice here we could do the equivalent ratios with our fractions. We could say this is times 20 and this is times 20. I'm going to skip the next question because we already did use models to prove that the percents are equivalent. And then what other fractions could represent 60%? We already said 3/5. Well, how about 30 out of 50? Or how about 6 out of 10? Or how about 9 out of 15? In order to get an equivalent fraction, you're going to multiply the top and the bottom by the same amount. A decimal might be 0.60 or simply 6/10.